Data warehousing. How to handle the data in your business with database. In this course, we will cover what is data warehousing, data everywhere yet, history of data warehousing, evolution in the organizational use of data warehouses, data warehouse architecture, strategic use of data warehousing, advantages and disadvantages, data marts. The learnings we need to derive from this course is what is data warehousing? What is the usage of data warehousing? Why it is important in technology? Is it safe in finding and using data are easy? Handling of data in a database. What is data warehousing? Data warehousing is the process of constructing and using a data warehouse. A data warehouse is constructed by integrating data from multiple heterogeneous sources that support analytical reporting, structured and or ad hoc queries, and decision making. A single, complete, and consistent store of data obtained from a variety of different sources made available to end users in what they can understand and use in a business context. A process of transforming data into information and making it available to users in a timely enough manner to make a difference. Data warehousing, a process. It is a relational or multi-dimensional database management system designed to support management decision making. A data warehousing is a copy of transaction data specifically structured for querying and reporting. Technique for assembling and managing data from various sources for the purpose of answering business questions, thus making decisions that were not previously possible. The data warehouse helps to optimize the business. Data warehousing is subject oriented. Data that gives information about a particular subject instead of about a company's ongoing operations. Integrated. Data that is gathered into the data warehouse from a variety of sources and merged into a coherent whole. Time variant. All the data in the data warehouse is identified with a particular time period. Non-volatile. Data is stable in a data warehouse. More data is added, but data is never removed. This enables management to gain a consistent picture of the business. Data warehousing is combining data from multiple and usually varied sources into one comprehensive and easily manipulated database. Common accessing systems of data warehousing include queries, analysis, and reporting. Because data warehousing creates one database in the end, the number of sources can be anything you want it to be, provided the system can handle the volume, of course. The final result, however, is homogeneous data, which can be more easily manipulated. Data everywhere, yet I can't find the data I need. Data is scattered over the network, many versions, subtle differences. I can't get the data I need. I need an expert to get the data. I can't understand the data I found. Available data poorly documented. I can't use the data I found. Results are unexpected. Data needs to be transformed from one form to another. History of data warehousing. The concept of data warehousing dates back to the late 1980s when IBM researchers Barry Devlin and Paul Murphy developed a business data warehouse. 1960s, General Mills and Dartmouth College, in a joint research project, developed the term dimensions and facts. 1970s, AC Nielsen and IRI provide dimensional data marts for retail sales. 1983, Teradata introduces a database management system specifically designed for decision support. 1988, Barry Devlin and Paul Murphy published the article An Architecture for Business and Information Systems in IBM System Journal, where they introduced the term Business Data Warehouse. Evolution in organizational use of data warehouses. Organizations generally start off with relatively simple use of data warehousing. Over time, more sophisticated use of data warehousing evolves. The following general stages of use of the data warehouses can be distinguished. Offline operational databases. Data warehouses in the initial stage are developed by simply copying the data off an operational system to another server where the processing load of reporting against the copied data does not impact the operational system's performance. Offline data warehouse. Data warehouse at this stage are updated from the data in the operational systems on a regular basis, and the data warehouse data is stored in a data structure designed to facilitate reporting. Real-time data warehouse. Data warehouses at this stage are updated every time an operational system performs a transaction. Integrated data warehouse. Data warehouses at this stage are updated every time an operational system performs a transaction. The data warehouses then generate transactions that are passed back into the operational systems. Data warehouse implementation. Whatever the data warehouse architecture, building a data warehouse is likely to consist of following steps: requirement analysis and capacity planning, hardware integration, modeling, physical modeling, sources, ETL, populate the data warehouse, user application, roll out the data warehouse and applications. The data has been selected from various sources and then integrate and store the data in a single and particular format. Data warehouses contain current detailed data, historical detailed data, lightly and highly summarized data, and metadata. Current and historical data are voluminous because they are stored at the highest level of detail. Lightly and highly summarized data are necessary to save processing time when the user requests them and are readily accessible. Metadata are data about data. It is important for designing, constructing, retrieving, and controlling the warehouse data. Technical metadata includes where the data comes from, how the data were changed, how the data are organized, how the data are stored, who owns the data, who is responsible for the data, and how to contact them, who can access the data, and the date of last update. Business metadata include what data are available, where the data are, what the data mean, how to access the data, predefined reports and queries, and how current the data are. Strategic use of data warehousing. Data warehousing is used across several industries such as airline, banking, credit cards, healthcare, investment and insurance, retail chain, telecommunications, personal care, and public sector. They're generally used in functional areas such as operations and marketing, product development, distribution, operations, and the strategic use include things such as crew assignment, customer service, new information service, fraud detection, risk management, trend analysis, new product and service promotions, distribution decisions, and intelligence gathering. Advantages: it provides businesses with a customer centric view of the company's heterogeneous data by helping to integrate data from sales, service, manufacturing, and distribution, and other customer related business systems. It provides added value to the company's customers by allowing them to access better information when data warehousing is coupled with internet technology. It consolidates the data about individual customers and provides a repository of all customer contacts for segmentation modeling, customer retention planning, and cross sales analysis. It removes barriers among functional areas by offering a way to reconcile views from multiple areas, thus providing a look at activities that cross functional lines. It reports on trends across multi-divisional, multinational operating units, including trends or relationships in areas such as merchandising, production planning, etc. Disadvantages of data warehousing. Data warehouses are not optimal environment for unstructured data. Because data must be extracted, transformed, and loaded into the warehouse, there is an element of latency in data warehouse. Over their life, data warehouses can have high cost, maintenance costs are high. Data warehouses can get outdated relatively quickly. There is a cost of delivering suboptimal information to the organization. There is often a fine line between data warehouses and operational systems. Duplicate expensive functionality may be developed, or functionality may be developed in the data warehouses that, in retrospect, should have been developed in the operational systems, and vice versa. Data marts. A data mart is a scaled down version of a data warehouse that focuses on a particular subject area. A data mart is a subset of an organizational data store, usually oriented to a specific purpose or major data subject that may be distributed to support business needs. Data marts are analytical data stores designed to focus on specific business functions for a specific community within an organization, usually designed to support the unique business requirements of a specified department or business process. Implemented as the first step in providing the usefulness of the technologies to solve business problems. Reasons for creating a data mart: easy access to frequently needed data, creates collective view by a group of users, improves end user response time, ease of creation in less time, lower cost than implementing a full data warehouse. Potential users are more clearly defined than in a full data warehouse. Characteristics of the departmental data mart. It's small, flexible, customized by department, online analytical processing, sources departmentally structured data warehouse. Cube Materialized View brings the fast update and fast query capabilities of the OLAP option to applications that query detailed relational tables as well as to applications that query cubes directly. A single cube materialized view can replace many of the relational materialized view of the summaries on a fact table, providing uniform response time to all summary data through query rewrite. Applications experience excellent query performance. Cube materialized views are cubes that have been enhanced to use the automatic refresh and query rewrite features of Oracle database. Summary data is generated and stored in a cube, and query rewrite is automatically redirects queries to the cube materialized views. Many of the same data dictionary views and PL SQL packages that support relational materialized views also support cube materialized views. Moreover, a group of PL/SQL subprograms in the DBMS cube supports the rapid deployment of cube materialized views from existing relational materialized views. Tools for creating and managing dimensional objects. Analytic Workspace Manager is the primary tool for creating, developing, and managing dimensional projects in Oracle database. Oracle OLAP is contained in the databases and its resources are managed using the same tools such as Oracle Enterprise Manager Database Control, Automatic Workload Repository, and Automatic Database Diagnostic Monitor. Thank you. CloudLearn Incorporated is headquartered in Silicon Valley, California. Our mission is to help enterprises provide an engaging and impactful learning experience that improves business performance. We provide the industry's most modern LMS. For more information, visit us at www.cloudlearn.com or reach out to us at info@cloudlearn.com.